Hello everyone, welcome to our pre-calculus pre-recording video. This lesson is about graphing logarithmic functions. Let's look at agenda. Review graphing exponential functions. So we'll just, because they are connected, logarithmic and exponential, so we'll review them a bit. Properties of logarithmic functions, transforming logarithmic functions, and then application of logarithmic exponents and logarithms. So our main goal for this lesson is logarithmic functions graphing. Okay, that is the main goal. So to understand logarithmic functions graph, we need to understand the graph of exponential function very well, since they are highly interconnected. Basically they are inverse of each other, so they are very important. if if you wish to review exponential functions graph, exponential functions properties, this is an example. Like e to the power x graph is this one. This way we can construct other graphs as well. Say for example, if we want to draw a graph of 2 to the power x, let's say 2 to the power x, this graph we wish to construct, that is fx equals 2 or fx equals 2. Let me bring some whiteboard and show you what will happen there. Oh, this is crazy. I should bring it. Okay, then it's good. So uh, let's go straight into logarithm, but we will go back and discuss it with how it works. Okay, we'll go back. Let's see how it happens. Suppose log 2 base x, we wish to construct it. Okay, y equals 2 or fx equals 2. How do we draw it? If you understand one graph very well, this will help you to understand other graphs or like extrapolate your knowledge for different situation. So let's think about what can we do about this x and 2, or how do we get the values, how do we calculate it. Okay, so let's write x here and log of 2 base x. Okay, and we'll try to put some um, value of x, and then we will try to construct the graph of it. Okay, suppose we know that the domain of a logarithmic function has to be this x has to be greater than 0. So basically 0 it cannot take, so and negative number also it cannot take, because domain is x is greater than 0. Okay, so that means x value has to be greater than 0. That means some positive number. Then say let's put some positive number. Let's put x equals to 1. Okay, x equals to 1. Then see what happens. Log 2 base 1. Log 2 base 1 equals to actually 0. The reason is this is how we calculate log. Suppose if I say log 2 base 4, 2 base 4 equals to what? The way we can do the calculation is, what power of 2 will make it 4, or will give us 4? What power of 2 will give us 4? Okay, that means if x equals to 4, then what power of this value equal to what? This is what we are trying to calculate. What power of 2 will give us 4? Answer is 2, because 2 to the power 2 equal to 4. Here, what power of 2 will give us 1? Actually 0. 2 to the power 0 equal to 1. That's why it is 0. That's why it is 0. Now let's say we want to calculate log 2 base, let's say 2 base 2. 2 equals to what? So 2 to the power what equals to 2? 2 to the power 1 equals to 2. Okay, that means if we put x equals to 2, answer is 1. This is answer line. Okay, this is the answer line. This is the answer line, and this line is for what we put x equals to. This way we can continue. let's say we want to put some value like 8. Okay, x equals to 8. So log 2 base x value is 8. So what power of 2 will make it 8, or 2 to the power what equals to 8, 2 to the power what equals to 8, 2 to the power 3 equals to 8, right? 2 to the power 3 equals to 8. So that means this equals to 3. Okay, now if we try to construct the graph of it, how do we do it? So let's use the eraser. Okay. Now we'll try to graph it here. Of course, the graph will be slightly approximate. Okay, so let's take some other color. 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, this side is, this is -1, -2, like this, and this is 1, 2, 3. This is y-axis. Notice that we haven't taken any smaller value of x, which we could have taken it. And let me show you actually, if we take one small value of x, how it works. Suppose log 2 base 1 divided by 4. 1 divided by 4. Okay, log 2 base 1 divided by 4. This equals to what? This is just to show you some small value how it comes. This equals to what? 2 to the power what equals to 1 by 4. If it looks difficult to calculate, what can you do is log 2 base, log, we can convert it to, suppose this equals to what, we do not know, this equals to say m. So m equals to, we'll try to find out, that means 1 by 4 equals to 2 to the power m. Okay, so this is actually 1 by 2 whole square equals to 2 to the power m. And this means what? This means we can write it as 2 to the power like -2 kind of. So 2 to the power m, m equals to -2, m equals to -2. So we can write here -2. So basically when it is x equals to 1 by 4, 1 by 4 means 0.25. When it is 0.25, at that time the value is -2. This is actually y value. Y value is -2. Okay. Now, so this is what happened here. Now let's construct it. Let's try to construct it. Take this color. So first of all, for 1 it is 0. When x equals to 1, y equals to 0, this point. When x equals to 2, y equals to 1. When x equals to 2, y equals to 1 is this point. When x equals to 4, y equals to 2. So 1, 2, 3, 4, and 4 is here. So this point. For 8 it is 3. So 1, 2, 3, 4, 5, 6, 7, 8. For 8 it is 3 somewhere here. Then for 0.25 it is -2. For 0.25 is somewhere here. It is -2. It is -2. So these are our points. These are our points. Okay. Now we can just join it. We can just join it to get our final graph. This will come closer and closer to the y line. but it will not cross this line because we know that the x value cannot be negative. X value will not be negative here. Okay, so that's why the graph will not go to the other side of the y line. Okay, so this is log 2 base 2 base x graph. Okay, log 2 base x graph. This is the most important graph in logarithm. Log 2 base x, 3 base x, or e base x, whatever it is. All the shape will be like this. And let me show you what does it mean. Suppose if someone says, okay, draw log 3 base x graph, then the graph will be this same shape. If someone says that draw the graph of log 2 base x, e base x, the shape will be same. Shape will be same. The shape will be same. Just the value, due to this 3, the value will be slightly different. The value will be slightly different. Okay. Suppose if it is log 3 base, suppose here it is 9, then it will be, the entire value will be 2 at that case. Okay. If it is x equals to 9, then at that time log 3 base 9 equal to, answer will be 2. Do you get it? So that will be the difference. Here if it is 9, then it will be 2 here. Then we can plot it, but this will be the shape. This will be the shape. This is what I mean. This has a very strong implication in all the graph of logarithm. Okay, when you try to transform it from different angle. Let me show you what we mean by that. Very important. You will see what we discuss here. We can actually apply it everywhere. So we said that log 2 base x, this graph is this. Okay, we just have drawn it. Now let's say you have a question. You can ask me, sir, how do I draw the graph of log 2 base, let's say minus x. Let's say log 2 base, let's say you want to give a minus before it. Or you can make a difficult question and you can say, sir, I want to give a minus here and then I want to give a minus outside of this logarithm. Then how do you draw it? Okay, suppose we said that this is the graph of log 2 base x. Then how you can draw the graph of log of 2 base minus x? How do you draw it? So the trick is here. Let's get some coordinate axis. Okay, roughly let's suppose that these are okay. Then we have, this is our x-axis everywhere, x-axis. For minus x, when you have a minus x, what will happen is this entire graph will shift about the vertical axis, y-axis. Okay, so this graph will have this shape. This graph will have this shape. This graph will have this shape. Do you understand? And why? You can ask me, sir, tell us why. Then the answer is this. See, suppose when our value of x was 2, let's say 2 or 4. Let's use a big value, 4. Okay, relatively big value. When x equals to 4, y equals to what? Or if x equals to what? Or log of 2 base x equals to what? At that time, it was, answer was, when x equals to 4, it was 2, right? Answer was 2. Here, you cannot put 4 here. You have to put minus 4 because there is a minus here. So here, you will have to put x equals to minus 4. If you put x equals to minus 4, then your y will come as 2, plus 2. Let me show you what I mean by that. Okay, so log 2 base, this is minus, this minus is coming from the from this value, then x value is minus 4, then minus 4, so minus minus it becomes plus, log 2 base 4, log 2 base 4 equals to 2, this 2 is here. Okay, so this is what we mean by this. If the value of x is minus 4 somewhere here, we are estimating somewhere here, then at the time our function's value is 2, y value is 2. Do you understand? So the shape of the graph is this. You can check with many other values and answer will come the same. Okay, so this is how we understand which graph is which one. Now what happens if we give a minus before the function, before this log 2 base x, what will happen? Look at this graph. This graph will have a x-axis shift or x-axis reflection. X-axis reflection is the better word, reflection. So what will happen is, if that graph has an x-axis reflection, kind of this graph should kind of this, okay, x-axis reflection, this graph and this graph. Always, this graph we have drawn in detail. The reason is all other question will come from this graph. Okay, so x-axis reflection is here because of the minus outside, x-axis reflection. Then this is minus and minus, double minus. This is double minus. So what do you do about this? Oh my god, this is crazy. Okay, but so what does it mean? It means that first of all you will have to do a reflection for this starting graph, one reflection about x, another again then a reflection about y, this graph. Okay, which is basically, if you do the reflection for this graph, then it should give us the answer, because we already have reflected it once about the x-axis. Now we will reflect it about the y-axis, then it should give us the solution. Kind of this graph, kind of this one, because there is double minus, so there will be double reflection. One time reflection about x, another time reflection about y. Okay, now let me connect it with the exponential graph so that you can see what happens, what is happening here. And I will draw it, although it will look little bit congested here, but still I will draw it here so that you all can see the connection. Suppose 2 to the power x graph. 2 to the power x graph is which one? Something like, let's use some other color. Okay, for exponential, let's use some other color. Let's use red. So this is the 2 to the power x graph. Y equal to, or if x equals to, you can say. Okay, very good. So 2 to the power minus x graph is which one? 2 to the power minus x graph is this one. This one. Now, okay, all right, then minus 2 to the power x graph is which one? That will be this one. Okay, then minus 2 to the power x graph is which one? Minus minus, double minus. So minus, then minus 2 to the power x graph is which one? Okay, so this one will be C, this graph. Okay, there is a minus here, so we need to give a minus. That means we'll just reflect this graph here, or you can just see this one also. This one's reflection basically. So this. Okay, so these are the things. Now see the connection, how they are interconnected. Okay, notice that if the minus is outside the whole thing, then it is a x-axis reflection. X-axis reflection. So if you see the minus outside, this will be x reflection. X reflection. Okay. If you see the minus outside, it will be x-axis reflection. Same thing goes. If it is minus within the x, with the x, it is y-axis reflection. It is y-axis reflection. Y reflection. See, this is y reflection. This one and this one, y reflection. So this is the technique, and this is not so the concept is not new. This is what we are trying to this is the point that we are trying to make here. The concept is not new, concept is same rule we are applying here. Basically the rule that we applied in the exponential function, we are using the same rule here. And actually we can construct their relative exponential function from the a logarithmic function, or from the logarithmic function we can draw their relative exponential function. Let me tell you what I mean by that. We already have constructed it, so you have the clear idea about this graph. What we will do is, like if you understand all these concepts very well, then the other things will just take very little time, you know. So what you know about exponential and logarithm is, many times, multiple times, we always say they are inverse of each other, they are inverse of each other, and all these things, right? Now inverse means, already you know, if some function is inverse with some other function, their domain and range will interchange. You understand? Just all the x value of some function will be the y value of the inverse function, and y value will become the x value of the inverse function, right? Very good. So these are the x value. So let's write it here: 1, 2, 8, 0.5. Okay, these are the x value here. So let's write it here. All right. So then their respective this value, let's write it here. Okay. So this will be 0. This will be 1. This will be what? 2. This is 3. So, oh, I have missed one value. See, this is what is bothering me. So, for this is 2, this is 3, and this is minus 2. Okay, this is minus 2. Let's try to plot it. Okay, let's try to plot it. So, this is minus 1, minus 2, minus 3, etc. So, for x equals to 0, y equals to 1, that means this point. For x equals to 1, y equals to 2, so that means this point. For x equals to 2, y equals to 4. So for x equals to 2, y equals to 4 is somewhere here. Then for x equals to minus 2, y equal to 0.5. So this is minus 2 and this is 0.25. So this is the thing. And see, notice this. This is actually, if we try to draw the graph now, let's take some unusual color. So if we try to construct the graph now, see, we got that exponential graph. And this is what? This is 2 to the power x graph. Y equals to 2 to the power x graph. You understand? This is 2 to the power x graph. So you will not. So the trick is, now you are learning another trick. Suppose if you are like if you say, sir, I'm so weak in log and log is so crazy, I cannot do this calculation that you said at the beginning. Then the trick is, first you draw the graph of, or first you find out the value of the same function's exponential value, then just interchange the value to get your logarithmic graph. You understand? So easy. And this is true for all of them. This is true for all of them. This will be valid for all of them. Do you understand? This is true. You can come from exponential to logarithm or logarithm to exponential. Just what you will have to do is you switch the domain and range. Okay, all the x value will become the y value and y value will become the x value. The reason is they are the inverse function, inverse of each other. Okay, so you can in this you can take a screenshot of this and this, because you will have all the most important 8 graphs of exponential and logarithm. All the question in the exponential function will start from these 4 graphs, and all the question in the logarithmic function will start from these 4 graphs. All the question, I mean graph related all the questions. Okay, so they will start from here and here. Okay, now let's go back to the slide. All right. So now I think if you look at this, this will look easy now. What is happening is, in this function, domain is all real numbers since it is exponential. So in the left and right, it will it will expand in the both direction, and range is more than 0. Y is greater than 0. X-intercept, there is no x-intercept. Although it looks like there is, but actually in actual graph there is no x-intercept. Y-intercept is 1 because this value is 0, 1, and asymptote is x-axis. X-axis is the horizontal asymptote. And these graphs, logarithmic one is this one, as you have seen, logarithmic function. In this case, so we have constructed the log two ways. So we have constructed the log 2 base x. Basically this one is log e base x. Okay, ln x means log e base x, and e is just a number. E equal to 2.718. just this is a constant number like our pi, kind of. Pi equals to 3.1416 or 14159, etc., etc. We take the approximate value. This is called Euler's constant. So, and this is actually base of natural log. This is called natural log also, natural logarithm base also. So I mean, this is very important number. That's why n scientists actually likes this number very much, this e thing. So this is useful if we study it a bit. Okay, so what will happen here is, one important thing I should tell you is, remember our horizontal asymptote of exponential function was x-axis. Since we are drawing the inverse, now y-axis will be the asymptote. So the vertical asymptote will become, for our logarithm, vertical asymptote will become y-axis in this case. Okay, vertical asymptote y-axis, vertical asymptote. Because as I said, the graph will not go, go to the negative side. This graph. Someone may think like, oh sir, you have drawn some graph here where our graph went to the negative side. In fact, there are double negative. There are some extra negative with the x value, which multiplies our graph, which actually forcefully takes our graphs to there. Do you understand? In that case, x value itself is negative. That's why this is how it can go there. But if x value is positive, this is what it happens in actual case. In that case, in other case, x value, what is happening? Okay. Okay. So what I said in this point is our horizontal asymptote for our exponential is y-axis. So since it is inverse, in this case there will not be any horizontal, it will become the vertical asymptote. So vertical asymptote for the logarithm is y-axis. Y-axis means x equal to 0. Okay, at x equals to 0. So this is the comparison. Now transformation. Look, for transformation, all the concepts will remain same basically. Don't take the transformation too hard way. Don't take it too hard way. If you take it too hard way, then it will be always hard to you. Look, look. Let me tell you this. Just look at, just look at what is happening with your one very important point. Suppose this point is here. Oh, there is some line missing from here. Okay. Suppose this line is 1, 2, 3, 4, 5. Okay, there is one line missing from here. Suppose this point was here. Now this exact same point, let's say, go there, and with the entire graph. Okay, so say this graph becomes this, like this. What will happen then? So see, 1, 2, 3. That means this point moved 3 blocks up. That means if this graph name is ln x, if this graph name is ln x, ln x, then it will become ln x plus 3, because ln x graph moved 3 blocks up, so it will become ln x plus 3. Same thing will happen now if it come here or here or here, then it will become negative sign. Okay, negative sign. Suppose if this point now they write here, and suppose the graph is like this, something like this, then it will be ln x. This is minus 1, so it will become ln x minus 1. There is no bracket here, notice it. Because, see, another example. Suppose this point from here to, it comes to this place now. It comes to this place now. And the graph shape is, the shape of the graph is, let's say now this. Now, then what? Now what? Notice that this point moved 1, 2 to the right. So it will be ln bracket x minus 2. If it moves to the right side, then it becomes minus. If it moves to the left side, then it becomes plus. Okay. If this point come here, suppose let's say 1, 2, 3. Suppose graph comes here. Then what? This point 1, 2, 3. So it comes to 3 box to this side. This point. Now you can say, sir, why you are counting everything from this box, from this point? What is special about this point? This is a we have chosen some easy point. You can start with some other point also. This trick will work with any other point, but this point is relatively a good point because this is at on the x line, and we can easily understand where it is moving up and down, and this is, you know, not in the middle, some good point actually. So 1, 2, 3. So 3 box to the left. In that case, the shape of the graph will be something like this. So something like this. Okay, it will not cross this line, by the way. So the function will be ln x. Again, there will be bracket. Why? Left and right always bracket. Left and right always bracket. Up and down, no bracket. See, up and down, no bracket. Okay, so it goes 1, 2, 3 box to the left. So it will become plus 3. For left, plus. For right, minus. For up, plus. For down, minus. Okay, so this is what happens. And for this additional number here, for this 3, 0.3, you will have some stress or compression, kind of that kind of thing. Basically what it does is whatever the value of y you get, it multiplies that by 3. Okay, it multiplies that by 3. So for the plus 1, it goes 1 box up. This was the plus 1. For this 3, it multiplies the value by 3. That's why the graph actually goes little up. Okay, it multiplies the value by 3, so the relative value is now a little bit more. Suppose one of the value was here, the exact same value will become there now, because multiplied that value is multiplied by 3 now. This is the reason. And do you understand? Suppose it is 1, it is 2. If x equals to 2, if x equals to 2, at that time y value was here. Now for the red graph, since this value is multiplied by 3, now this value moved to that point. This is why this multiplication is happening. And for this negative, see, negative is outside. So if the negative is outside, then the reflection is about the x-axis. Transforming the thing. So if you left and right, for the negative, it goes to the right. 1, 2 box. That's why minus 2. Okay. It is 0.5. The value is less. If the value is more, so this is 0.5. 0.5. Okay. That's why it actually, for the 3, the graph was something like this. The graph was here, because at that time you are multiplying by 3, and this case you are multiplying by 0.5. 0.5 basically is you are multiplying by 1 by 2. Okay, that means you are making the number smaller. 0.5 multiplying by 0.5 means you are making the number smaller. Suppose if you multiply a number by number 20 by 0.5, it will become 10. That's why the value is becoming smaller. Yeah, smaller. Okay, and this is our, see, within the x is within the bracket, the minus is within the bracket with the x. That's why it is y-axis shift. Just most of the thing is just repeating what I said in the drawing. Okay, this is the summary of everything that we said so far. Summary of everything is here. All the things for 3. See, for 0.5, 3 is this graph, 0.5 is this graph. Red. Okay, red. Then blue. So blue color. You can compare it if you want, like what happens. This is for comparison. This is for the classwork. You will try to figure out which one and which one is matching. We will give you some answer here. Then other things we will try to match. This is this is the data taken from real world, like about this COVID, how it increased. And in terms of logarithmic scale, this is the graph. And some points. This graph is not exactly, by the way, exact logarithmic, because this is real world data. Real world data is never, they will not follow the exact shape of your logarithmic function, exact shape of your any function. They will not follow that by any means, because real world data is impacted by many external factors. Okay, but still you see the graph somewhat looks like logarithmic function. This is what is crazy about that. And they are exponential. See, when we use the data in terms of exponential, in terms of real value basically, then actually it is exponential, resembling somewhat exponential. And if we convert it to their relative logarithmic scale, then actually it becomes like this. And if we try to make a function now from this data, how it looks like. A simpler model is this one. N equals to, that means number of people infected will be 100 into 10 to the power x by 15. This is the cases increased by a factor of about 10 every 2 weeks since late January 2020. Every 2 weeks by a factor of 10. What does it mean? It means this x will mean after every 2 weeks what will happen. Okay, so that means if it is 4 weeks, then x equals to 2. If it is 6 weeks, then x equals to 3, because the model is every 2 weeks model. And then how this 100 comes? 100 comes because at 0, the value is 100. That is for initial value. How this 10 comes? Because you see, you divide 1000, this 1000 divided by 100, you get 10. This divided by this, you get 10. Okay. How this 15 comes? You see the difference here is 15, 15, 15. See, this is 45, 30, 15, 30, 15. Difference is 15, 15, 0. Difference is 15. Normally we take the value, we used to take the value where the gap is 1, 1, 1, 1. When you take the gap, when the gap is this big, then you have to divide it by this additional factor. So it is x divided by 10. We can convert it to its logarithmic function actually. If we can convert it to represent it by some e-related term, because e looks nicer. So 10 to the power x by 15 equals to what? 10 to the power x by 15, their equivalent is e to the power 2.3026 to the power x by 15. That means 10 means e to the power 2.3026. 10 means e to the power 20. E means 2.718. So 2.718 to the power 2.3026. This will give you 10. So we can write this as n equals to 100 e to the power 0.1535 of x. Now you can say, sir, why you are showing us all these things? The reason is, most of the time you will notice that we give you some math, or in the book they write you some math, and then they give you this line. And they say, okay, if x equals to this, do the calculation, find out the number of people who will be infected. Then this says, oh, if the number of people infected is, let's say, this, some other amount, then x equals to what, calculated. So normally you never see how this value actually they get. So this is one of the example how in the book they make the math. Do you understand? So this is how they make the math in the book. This is the internal mechanism how it works. I think that's all for today's class, actually, for today's recording. Most important thing here is you must know what is happening here in terms of logarithmic function transformation and all these things, all these graphs. And you all must know that 4 graphs, 8 graphs that I have shown in the drawing. That is most important. That should become your muscle memory. Do you understand? You should instantly be able to draw all those 8 graphs. Then you will be mastering actually graphing logarithm and exponential thing. Okay, this is the way. This is how you can draw. You can actually master it. Let me write it once again here. All those 8 graphs name. Okay, their name is, suppose if you write 2 to the power, so it will be, let me repeat it here. So 2 to the power x, then 2 to the power minus x, minus 2 to the power x, minus 2 to the power minus x. Then logarithm function is, this is the last minute of this recording. So suppose log 2 base x, log 2 base minus x, then minus log 2 base x, then log minus log 2 base minus x, and all of them, they are fx equals to, okay, fx equals to, fx equals to, fx equals to, I think you got the point. Then fx equals to, this is also fx equals to. These are the most important 8 graphs that you all should know. Then some people say, sir, I am so weak in graph, I do not understand. That's because you are weak in these 8 graphs. Because all the math starts here in the logarithmic exponent. Exponential graph starts here, logarithmic graph starts here. Do you understand? So you will need to draw this graph in your practice this graph in your notebook and etc. etc. All right. So thank you all. Thank you very much. Have a good day, everyone.